Section 7.3 is a fun section. It actually talks about repeating decimals. The applications are there. You have to work a little harder to see where they are. So you'll see some things in your group work and your homework that maybe are a little unexpected. But we're going to take a look at first is something that we saw back in section 1. Do you remember when we said that a fraction could be written as a terminating decimal? What did it take? This was one you watched on your own. I wasn't here to talk to you. You just listened to me. When was a fraction able to be written as a terminating decimal?
A 2 and a 5.
Okay, so it had to do with when the factors of the denominator were only 2s, they could have multiples of those, 5s, or both. So if your denominator could factor into 2s, 5s, or both, and I should say the factors of the reduced denominator. So what I mean is that if the fraction itself could be reduced, we had to simplify it first. Remember doing that, but we do have to do that to check first. So if there's anything else in the denominator, it's not going to work. So what if the fraction cannot be written as a terminating decimal? So it has something that's not a 2 and it's not a 5 in there, and 1 doesn't count either. 1 doesn't give you anything new, right? So it has a 3 in the denominator, or a 7 in the denominator, or an 11, or a 13 or something like that. It has some other number that's prime that's not 2 or 5. So when this happens, if the fraction is an integer over an integer, or we can change it so that it is, and does not terminate then it will repeat, at least eventually. Some numbers repeat very quickly. If you put some decimals, like 1, if you put fraction 1 over 3 in your calculator, it repeats immediately. 0.3333, you see it immediately. But if you grab your calculator and you put in the fraction 1 over 7, it will repeat, but it takes it a minute. In fact, it takes it 6 decimals before it repeats. Eventually it does, but it takes it a little while. Okay, so this doesn't tell you how fast it repeats, it just tells you that eventually it will. So as you're working on these, I should make the note. It's after this. Never mind. As you're working on these, we're going to be doing division to see at what point it's going to repeat. Yes, you're welcome to use your calculator to check things. I don't mind that at all. But your calculator cannot be the replacement of you. Okay. So when we're taking a look at this first one, 1 over 24. In order to decide if it's going to repeat or to terminate, we could factor the 24 in the denominator, and we could check it out. So let's just check it real quick so that you can see that this will happen. How could 24 factor? What was it? There's lots of options. Somebody give me one. 6 and 4. That's a good place to start. How will 6 factor? 2 and 3. And 4 is 2 and 2. So the 2's are no problem, right? But the 3 means that I'm going to have a repeating value. Agreed? Okay. So we're going to actually do the division now for 1 over 24. Please remember that a fraction is just another way of writing division. This means the same thing as this. Okay? 1 over 24 means 1 divided by 24. So we're going to take the number 1, we're going to put it underneath the division sign, and we're going to put the 24 on the outside. Now, you cannot just put 24 into 1. It's too small. So you need an additional place value. I'm going to put my decimal point in, but now I'm going to think about this number like it's the number 10, and I'm going to say, well, still it doesn't go in, right? It's not going to go into 10. So if you want to put a 0 above the 1, the decimal point moves up, and a 0 above the 0, it didn't go into 10. So I'm going to put another 0. Will 24 go into 100? Yes, it will. How many times? It'll go in 4 times. And you're welcome to use your calculator to check. I'm okay with that too. What is 4 times 24? 96. And we will subtract. So we've got the number essentially 100 minus the number 96. what does that give me? A 4. I've got a 4 there. 24 didn't go into 4, so I know that the remainder is an adequate answer, like it's not a red flag or something. So I'm going to put another 0, and I'm going to bring the 0 down. Okay, now how many times will 24 go into 40? Just once. 1 times 24 is 24, and I subtract. What is 40 minus 24? Close. 16. Yeah, 16. Again, 16 is smaller than 24, so we're still good. All right, we haven't missed the number that we were supposed to go into. We're going to put another 0 here. We're going to bring it down. So now I have the number 160. How many 24s will go into 160? It's 6. And what is 6 times 24? It's 144. And if we subtract, what do we get? 16. At this point, what I've just gotten in my remainder is a remainder I got right here. Isn't it? That tells you you're at the point where something's going to repeat. And if you don't quite know what's going to happen yet, you can continue on a couple steps to see, right? If I put another 0 in here and I bring that 0 down again, I have the number 160 again. I get the number 6, and then forevermore, this is going to be 6 repeating. Now, it doesn't always just repeat one number, but this one does. The 6 is the only thing repeating. So at this point, this 6 repeats. The first time it repeats is the place where we want to put the bar on top. So you can put the 0 point at the front, or you can just put a point 0. This is 4, 1, 6. The 6 at the beginning of the list of repeating 6s is the one that we mark with a repeating bar on top, and we're done. Okay, we'll do another example that doesn't repeat after just one place. But this one did. So this is what we have. Now, you got to show me the division. I mentioned this in 7.1 anyway, but this type of a decimal is called a repeating decimal. The repeating block of digits, in this case it was just the number 6, is called the repeat end. Okay, repeat end. So that piece could have one decimal like ours did, or it could have more than one. I want to see you show the division, and we're going to do an example now for 29 divided by 99. You may know what this one is as a decimal. It's got a certain form that's very nice to know it as a decimal. You may not. Either way is okay. But let's take a look. So the 29 over 99 is the same as this division. So 29 will go underneath and 99 on the outside. 99 is bigger than 29, so we have to put a decimal and a 0. I'm going to 29. But how many times will it go into 290? It'll go in twice. What is 2 times 99? 198, yes. And we subtract, and what are we going to get? Somebody said it. I thought. 92 is correct, yes. It's smaller than 99, right? So we used the right number at the top. It was a 2. We'll put another 0 and then bring it down. 920. How many 99s go into 920? There's 9. What's 9 times 99? 8, what was it? 891. Wonderful. When I subtract this, what do I get? 29. Have I had a 29 before? I happened to start with a 29 here at the beginning. So I'm going to show you that this is going to happen, but the reality is this 2 and this 9 that are above my house for my division are going to repeat, both of them this time. It's going to keep going 29, 29, 29, 29. And I can tell you that it's going to repeat because it went back to 2 steps. And if you aren't sure, that's okay. How you can tell is by continuing the process just a few steps further. You put in a 0 and you recognize this goes in 2 times. And you get 198, and then you get a 92. And then you put in a 0 and you recognize this goes in 9 times. And you get a 891 and a remainder of 29. Right? this piece, the 8, the 2, and the 9 are what's repeating. So when I write my repeating decimal, both the bar goes over both the 2 and the 9. Feel free to write the 0 in front, or feel free not to write the 0 in front. Either way is okay. And we have this. Okay, we're going to stop there because we shift gears when we move into question number 3. Okay? It's a good place for us to pick up next time.